You are tuned in to the network, the channel that dumbs down topics from the CCNA and CCNP exams. Today's topic is 5.4 C Unicast reverse path forwarding. This is the topic in the CCNP route exam. It will be known as the CCNP Enterprise exam come February 24th, 2020. Let's take a look at the exam blueprint and see where we came from and where we're headed. Hashtag lab every day. Go ahead and join that community. Shout out to my boy Duan and visit labeveryday.com. All right, so this is the exam blueprint implementing Cisco IP routing, exam code 300-101. The new code is 300-401. We just wrapped up the section 5.4B, IPv6 traffic filter, which is basically ACLs for IPv6. And today we're going to do, again, uRPF. And we're finally going to move on to section 6, which is infrastructure services. That's the final section, but that nonetheless, that is 20% of the exam. So yeah, what is uRPF? When I think about this topic, I think about the United States Postal Service rather, or if you're in another country, DHL or something like that. So what is uRPF? It's similar to how the United States Postal Service or any other postal service processes suspicious packages, right? If you look at this picture right here, if we receive a suspicious letter, or if we receive packages that have, oily stains or excessive tape, it's rigid or boldy. This is real important right here. No return address, restrictive markings, etc. We deem these packages as suspicious, right? Well, in the networking field, we would deem these packages kind of like spoofed packets, right? It's a packet that's just it did not come from a reliable or valid source. And uRPF is a way to kind of mitigate this problem. And the way it does that, let's talk about the official definition of uRPF. uRPF stands for Unicast Reverse Path Forwarding. Network administrators can use Unicast Reverse Path Forwarding to help limit the malicious traffic on an enterprise network. This security feature works by enabling a router to verify the reachability of the source address in packets being forwarded. This capability can limit the appearance of spoofed addresses on a network. If the source IP address is not valid, the packet is discarded. So it's kind of like if I receive a package and it says Donald Trump on it, addressed to me. I'm not going to get a package from Donald Trump. I'm not, shout out to the Republicans, but I'm not a big Donald Trump fan. So
look at my African American over here. Look at him.
I know it's not a valid source. I might return that package, or I might, toss it in the dumpster. I don't know, something. I'm not going to process it like it's a regular package, right? Now, if you look at this network topology, it's a real simple network topology to explain this topic, right? Shout out to networklessons.com for this topology, this example right here. We got router 1 with the routing table with just one network, right? This is just for simplicity, right? He knows about the 2 network via FA00, which is this interface right up here, right? So if he receives a packet that is that comes from the 2.2.2.2, or basically the 2.2.2.0 network, then he's going to process it as a regular packet, right? But if he receives a packet from 2.2.2.2 from FA01, he's going to drop that packet because he knows the 2 network, it lies off of FA00, so he's not going to process it like a regular packet. This is how we prevent spoofed, DDoS attacks. We can prevent spoofed addresses from being processed on our network. This is how it works. During normal operation, a router checks the this is how a router normally works, right? He sees that he gets a packet and he knows it's destined for a specific network. He sees the destination address. He processes it. If he has it in his routing table, he will send it. Now, uRPF will check not only just the destination, but it also checks where it came from, or the source IP address. The router will also look at the source address in order to prevent traffic from spoofed IP addresses. So basically, if it comes from the spoofed IP address, it's going to drop the packet, right? And if you log the message, if you have an access control list, we'll get a syslog message saying, we dropped this packet because it did not come from the right interface. If it came from the right interface, we may or may not process it, depending on how you have this set up. This is done by verifying if the router can even reach the source IP. So if we can reach the source IP, one check that's passed, right? If the source address is valid, it will be forwarded. If it's not, it'll be dropped. Simply put, we look at this example right here. We have a packet that is destined for the 444 network, right? That lies over here on router 4, right? loop back 4. So we send them a packet and it goes over here, right? But if it goes to router 3, it'll be dropped because we know the 4 network is not on router 3. So he's going to drop that packet. It was destined for router 4. So, but why would he forward that packet, right? Well, I don't know. Maybe something set up on router 4 that he forwarded to that packet. I don't really like that example. If somebody can help me read that topology, but I don't think it was supposed to, be destined for that network. That's why it got dropped anyways. But uRPF helps limit this. So uRPF has 2 modes. We basically loose mode and strict mode. It's just like, high or low, strong or, weak. Just basically it. There's actually a VRF mode, but that's kind of out of scope of this exam. So technically uRPF has 3 modes. But for the sake of this exam, just know that we have 2 modes that we need to worry about. Loose mode checks the routing table to see if the route exists for the source IP address, right? So we check the source IP and see where it came from. Can we reach this IP address? If so, then we'll process it. Note, this cannot be a default route or route to null 0. So if we have a packet that's destined for a default route, we're not going to just process it. There's also strict mode. It's just like loose mode, but the route must be in the routing table and the packet must come in on the interface associated with that route. So this is more, obviously, it's more strict. It's a more restrictive mode. So we're checking. We have 2 checks that we need to pass before we process this packet. How do we enable it? We go to the interface and type in IP verify unicast source. Remember, you can question mark through the exam. So if you do have a simulator that requires for you to set this up, which I doubt you're gonna have to configure this. You can question mark your way through it, but if you do have a multiple choice, you do have to kind of remember how this is set up. So IP verify unicast source reachable via, and now these are the 2 different modes, right? Any for loose, RX for strict. That's basically it. Allow default, that's an optional mode. This allows uRPF to use a default route if the network is not found in the FIB. What's FIB? Forwarding information base. This option can be used with either strict or loose mode. You'd also put, I believe, you could put an access control list at the very end. That's how we could log our messages. So you can, how you do an access control list like we did in the last couple of videos. You get matches. That's how you know if we're dropping packets due to uRPF, we could log what packets we drop. Now, if you have an AFC firewall, I'll show you an example of that as well. We verify with show. Well, on a regular router, we just do show CEF interface, and you put the interface name, and then you can see whether unicast RPF or uRPF has been turned on or not, right? For that interface. Now, on an ASA firewall, it's not, which is out of course of this exam, but if you're doing security, CCNA security, you do show IP verify statistics, and you can see the actual packets being dropped, on the inside interface and the outside interface, and also on your VPN as well. So that is one way you can verify it. And again, you could also verify it on a regular router. You just do you just create an ACL for this, and then you can see the packets being dropped. And you could also log it by doing a log keyword at the end of your ACL. So let's go ahead and fire up GNS3 and experiment with unicast reverse path forwarding. Again, shout out to gns3vote.com. You can get the lab topology there. Also, you can also get the lab solutions there. So if you don't like the way I'm teaching it and you like his teaching style, he also performs this lab and gives you the solution on how to do this as well. So I don't want to take credit for a lot of these labs that I've been doing on my channel came from gns3vote.com. A lot of them came from Boston NetSim as well. I'm just performing it and explaining it the way I explain it. All right, here's the lab we're going to be working with today. We got 3 steps to do here. We got router catch, router mirror, and router flash here. Again, we'll rename them all now with these weird router names. Anyway, step 1 says configure router mirror, which is located right here. So traffic on the FA10 interface, which is located right here, will be dropped if the source IP address does not match the next hop address that router mirror has in its routing table, right? So basically, we know we need to go to router mirror to do all of that. So right now, we're going to go ahead and console into router mirror, right? And see what he got in his, we're going to take a look at that interface and also look at his routing table, right? So Also, let's look at the topology again. We got the 12 network right here, 192.168.12.0. We got 192.168.23.0 over here, right? Let's look at this route table, show IP routes. And also OSPF is installed or configured on here, right? We got the 3.3.3. I believe that's a loopback on Flash. And also quad 1, which is router catch, right? So those are learned via OSPF, right? That's what those O's stand for. And we're connected to the 12 network as well as the 23 network, which were those connected lines that I showed you earlier, right? So those are the networks that he knows about. Let's do this. Let's check. We know obviously we're going to have to turn on uRPF to do this, right? So how do we verify? We said that to verify it, we have to do show IP CEF. The interface they said that we wanted to work on was FA10, right? FA10, which is right there. FA1, 0 or /0. And that's the next hop IP addresses that we need to know that they can reach. Really what we needed to do though was CEF interface FA1/0. And this is how we know no access lists have been configured, but Unicast RPF check is disabled. We want to enable it here, right? But what mode, strict or loose? Well, he said we wanted to drop the source IP if it doesn't match the router, that it has match the address that the router mirror has on this routing table. So that means loose mode checks the routing table if the route exists for the source address. That's all he said, was source address. Strict mode is just like loose mode, but he also checks the routing table and the packet must have come on the interface associated with that route. They didn't ask us to do all that. So basically, we need to do loose mode. So we need to obviously go to global config mode, configure terminal. How many times y'all did that before, right? Interface FA1/0. And before we do that, let's also check what happens when we actually do ping it, right? So we're going to log into Flash as well. Actually, no, let's just continue. We said to do strict mode, to enable uRPF, we do IP verify unicast source, reachable via, and we do any for loose mode, and RX for strict mode, right? There's something about this keyword that I want to show y'all as well. So now that we're on that interface, we do IP verify unicast, and then before we do source, there's also reverse path and source, right? The thing about source is they're pretty much the same thing, is that reverse path is an old command. So basically it's a deprecated command, but you can still use it on here. Also, I believe reverse path is the only function for an ASA firewall. So you're not gonna, I don't think you'll find source on an ASA firewall. Correct me if I'm wrong. I do have a firewall back here actually. I just haven't really played with it yet. I'll verify that for y'all as well. But I believe that's only for that firewalls only does reverse path. So we're gonna do source in this case, since that's what I taught y'all. Reachable via. We said via any interface or via the interface at which it was received, right? We said any interface. So traffic on the FA10 interface will be dropped if the source IP does not match the next hop, right? On this one, they say, because we have another one that we need to do on the other interface. He says it'll drop if the source IP doesn't match anything. So doesn't match anything means any. So right now, we really need to do RX, strict mode. Doesn't match the next hop it has on this routing table. So we're going to go with RX for now. Now, here's the other options we can do. We can create an access control list to reference this to, and we'll do one for, let's say 1300, right? And then we'll play with that access control list later. As far as logging, we'll have to create an access control list as well, right? So now that we've done that, we're going to go to Flash and see what happens when we try to ping that, right? We're going to have Flash ping catch. So that means he's going to go through that interface and go to catch, right? Now, he should have catch, I believe, is quad 1, right? But let's verify that anyway. All right, we're in Flash. And while we do that, show IP interface brief. Yes, he's quad 3. So we're going to have him ping quad 1. That worked, right? Let's ping him with a different interface. Loop back 0. Well, So let me show you something. Mirror should theoretically know about that interface on, let's do this, show IP route. So he knows about the quad 3 interface, right? From Flash. So loopback, my bad, source, loopback 0. That went, right? So let's create basically a loopback that Mirror does not know about, right? So we're going to say, so we're on Flash right now. Let's do a show run and take a look at his OSPF real quick. Again, you could go on gns3vote.com for the, Renee Molnar's video solution. I just kind of break it down my way. So we're doing OSPF on all the routes here, on all interfaces here. Let's go to global config mode and router OSPF. Actually, we're going to create a loopback. Let's create a loopback. Let's create a loopback 5, right? We're going to give him the IP address of 55.55.55.55. 255.255.255.255/32 pretty much. And now that he's up, and we're gonna fix OSPF that so that way this interface is not being advertised, right? So we're gonna get rid of the all interfaces here. 255.255.255.255. No, network that, right? Control A, network. And we're going to say, oh, area 0, my bad. We got to do an area. And we're going to say network. See, not network. Now that one is down. We're going to advertise the 23.0 network. So network 192.168.23.0 quad 255 area 0. And we're also going to advertise the loopback as well, which was 3.3.3.3 0.255 area 0. Okay, so now we're advertising the connected interface as well as the loopback, but we're not advertising the 55.55, right? So let's go to mirror and you'll see show IP route. He don't know about the 55.55 network. So theoretically, he should be like, what is this? I don't know what this is. This came from Donald Trump. We're going to have Flash try to ping catch, right, through that interface. Ping 1.1.1.1. That worked. But now we're going to ping it with the source IP of loopback 5. And as you can see there, it's hanging. Now we go to mirror. We don't see those packets being dropped or anything, right? But if we do a show, first of all, let's do this. Let's check our interface here real quick. Show IP, show CEF interface FA1/0. And as you can see here, Unicast RPF is enabled. So we enabled it this time. But how do we check to see if those packets are being dropped? Well, that's where the ACL comes from, right? We should have done a log there, which was, I believe, the last step here. Configure router mirror so all drop packets are logged. And that's what we should have done with that ACL. So we're going to go to global config mode. I guess we're skipping step 2 here. IP access list extended 1300. Invalid access. Name. We don't want to do name there. So we got to do just access list extended. Access list 1300. We're going to say deny deny any log. And we'll deny log. And that's how we're referencing it with that IP address. I mean, with that that uRPF that we just did, and we added the 1300. Now that 1300 is going to reference this access list. So let's try that again. We're going to have Flash ping catch. I guess I'm kind of skipping the steps here. Have Flash ping catch with that different source IP, right? We go back to mirror, and now you can see that it's being blocked right there, right? That's the log that we just created there. Another thing we can do is show access list, and you can see right there we got 5 matches. Now, if you have an ASA firewall, again, you can just do show IP verify statistics. You can see your actual RPF drops. With this, we got to kind of manipulate it by creating an access control list and then log our drops that way. Now, I kind of went backwards, I guess. Let's go ahead and do the same thing on FA10. So basically, we're just going to be doing it the other way, right? So he says to drop source IP packets that doesn't match anything router mirror has in its table. That doesn't drop, so he doesn't match anything. When we say anything, we're going to use the keyword any, right? Because that's what we did on the other one, right? Or we did RX on the other one. Yeah. So for that first one, we did RX. On this next one, we got to pretty much do this same thing right here on the other router, which is this guy, catch. But we're going to do it on that interface is where we got to place that command. So we got to go to interface FA00, go to config mode, and let's do a show CEF interface FA00. And as you can see, uRPF check is disabled, right? And we're going to go in interface FA00. Now that we're here, we're going to say IP verify unicast source reachable-via, and we're going to say any. And then we're going to say 1400 for the access control list, right? And we have to create an access control list to log that, right? Let's go ahead and do that as well. Get out of this. Actually, global config mode, access list. We're going to say 1400, deny any log. And that's how we're going to log those messages. And then we're going to go to flash, and let's try to ping. We're going to have not flash. We're going to have catch ping flash, right? So we got to go to catch. We got to do the same thing, but ping flash. Flash's IP address was show IP interface brief 3.3, right? So we're going to have him ping 3.3.3.3. Of course, he can ping it, but we have to create a loopback that mirror does not know about, right? So let's say we pinged it with a loopback 0, which he knows about, right? Source mirror should know about that one, right? So that went through, right? We need to create a loopback or something, an IP address that he don't know about, kind of spoofing, right? So we got to trick him. We got to play Donald Trump here.
These dishonest people.
We're gonna go global config mode. Let's do a loopback 10. We're gonna give it an IP address 10.10.10.10 255 network. Subnet. And then we gotta get rid of the SPF 1, I believe it is. Let's do a network 3.3.3.3 so that way it'll stay up. 0.255. 0. Let's do 255 area 0, and then let's get rid of the network quad 0, so that way we're not advertising all of our networks. Don't forget the no to get rid of it. It went down that time. We need to make sure we are advertising the 23.0 network. Let's do that. Network 192.168.23.0 area 0. Get rid of that. Now OSPF is back up. So actually, let's just ping him. Let's go ahead and ping it now. And that's being blocked. We go to mirror. There's the access denied from the access control list, 1400. Remember the first one we blocked it using 1300. We blocked this one using access control list 1400. And again, we could do a show access list to see what's being blocked here. And there's our other match. We can ping it again just to verify using catch. Right. Go back to mirror. And you can see pings are being logged here. And that's one way to verify that you are being attacked or getting a DDoS attack or anything. That is my YouTube page. That is my Twitter handle. Go ahead and add me on Twitter. Send me a message. Send me a shout out, whatever. Go ahead and please leave a comment below. Let me know how I can improve these videos. I know better lighting and a better microphone will help, obviously. Go ahead and share this video. Please hit the like button. Hit the subscribe button. There's a notification bell. That'll let you know when I upload these videos. I'm trying to do these daily so I can churn these out so I can go ahead and take this exam. Let's get certified, y'all. For now, go ahead and comment, like, subscribe to the network.